Hello, my name is Alan Russell. This is FTE 217 Modern Sporting Rifles, Week 3 assignment. Okay, today we're going to be doing an analysis of 5 different AR-15 components. Critical dimensions first, we're going to be talking about the buffer assembly. The critical metric for that is going to be weight, and it's going to be for AR-15 between 3 and 5.4 ounces. The next one we're going to talk about is gas block. The internal dimension is going to be 0.750 inches to 0.625 inches. Next one is going to be the firing pin, and that's going to be the protrusion. It's going to be 0.028 inches to 0.036 inches. The next one is going to be magazine, and that primary key metric is going to be feed lip gap, and that's going to be approximately 0.450 inches. And the final one is going to be the extractor itself, and the key metric there is going to be hook angle and pocket depth. So when we talk about the buffer assembly, we're going to be looking at weight and compressibility. The potential malfunctions include if the buffer is too light or the spring is too weak, it can cause overgassing. This causes different types of malfunctions such as failure to eject, failure to extract, or bolt override, which is failure to feed. That's because the BCG is driven rearward with too much force, right? The damages this can cause is buffer disintegration, set screw shearing, chipped or broken extractor claws, or deformed carrier key and screws, right? If the buffer's too heavy or the spring's too strong, it causes, opposite, it'll cause undergassing, right? And that's where the BCG is not driven rearward with enough force to fully compress the spring. That's going to cause short stroking, which again is failure to speed, failure to lock back on the empty magazine, or even failure to chamber. The types of damages that's going to cause is mushrooming or flattening the buffer face, deformed bolt catch, accelerated wear on buffer springs, damaged feed ramps, and bullet deformation. Next, we're going to talk about gas block. Critical dimension here is going to be alignment to the barrel port. Malfunctions are going to be such as short stroking, failure to feed, again, failure to lock back, failure to eject, failure to extract, and a complete failure to cycle. All right. The types of damages it can cause is going to be a permanent deformation of the port, gas cutting, which is scoring or pitting the exterior of the barrel journal, accelerated thermal wear and or warping of the gas tube, and then carbon welding, which is fusing the gas block to the barrel. Right. Next, we're going to discuss the firing pin. And basically the critical dimension there, as we talked about earlier, is protrusion past the breech face. And malfunctions, if it's too short, is going to be failure to fire or light strikes, hang fires or misfires. And the types of damages that can cause would be hardening and deforming of the firing pin tail, fracturing the firing pin retaining pin, accelerated internal bolt channel wear and peening, hammer face indentation, and chamber and feed ramp peening. If it's too long, on the other hand, it's going to cause pierced primers or backgas venting, severe backgas venting, and even slam fires, right? The damages that's going to cause is going to be stripping, pitting, and binding of the extractor claw and springs, bending of the firing pin retaining pin, gas key fastener stretching and leakage, severe pitting and erosion of the firing pin tip and the aperture, and then of course magazine body distortion and damage to the fire control group. Right. Next, we're going to talk about magazine assembly. The feed lip gap is and then catch notch height are the two main things that we're concerned with there. The types of malfunctions we're going to see are going to be failure to feed, round diving, that kind of thing. Double feed if the lids are splayed too much. Base over base caused by a weak spring. Failure to lock back, or even seating, improper seating, or even not be retention, so the magazine just falls out, or that kind of thing. So the damage is going to cause is going to gouging of the feed ramp, peening or chipping of the bolt locking lugs, accelerated wear of the bolt catch, scoring and or burning of the upper receiver, and of course ammunition case net ruptures. Right. The final one we're going to talk about is the extractor, and the critical dimensions there are about the hook depth and the rim engagement angle. That's a mouthful. The malfunctions we're going to see are failure to extract or stovepiping, failure to eject, failure to lock a cheat battery, not failure to lock back. Bolt over base, which is the double feed or feed angle failures. The type of damages we're going to see are peening, deformation, or blunting of the ejector pin, micro fractures or shearing of the bolt locking lugs, gouging and or burring of the barrel extension locking recesses, scoring and scratching of chamber walls, and of course damage to ammunition case rims and debris fouling. Right. Moving on, the gunsmith training that I think is really important for us all to have is going to be proficiency with all the different measuring tools, micrometers, pen gauges, calipers, those type of tools. We're also going to need to fully understand the cycle of operations. And finally, we need to be able to perform, we need training in QA standards. So we're able to perform serviceability checks, component interaction, magazine, you're going to interact with the magazine catch and the mag well. Extractor is going to interact with the bolt face and the rim groove. Buffer is going to interact with the receiver extension and the spring. Gas block is going to interact with the barrel gas port. And then the firing pin is going to interact with the bolt chamber or hammer. The references I used for this were ssusa.org and brownells.com.